Hi everyone, let's solve the today's LeetCode challenge, which is maximum element after decreasing and rearranging. So I have rephrased this problem statement for a better understanding while retaining the key information. So here we are given a positive integer array and we need to perform some kind of operation on that to satisfy the following condition. So this is the condition that our final array should meet, and we are allowed to perform these two operations over our input array. So first one is decrease the value. We can decrease the value of any element to a smaller positive integer. So let's say if at any moment we have 4 and we want to make it 3, then that is possible, but we cannot increment the value at any index and rearrange the element, and we can rearrange the element within the array itself, given array itself. We are given this array and we need to convert these array to be able to satisfy these conditions. The first element should always be 1. Okay, the first element should always be 1, and the absolute difference between any two adjacent element must be less than or equal to 1. So after 1, for all the element, the difference between any two adjacent element should be less than or equal to 1. So these two conditions our resultant array should follow, and after that we'll just have to return the maximum value in this array. Okay, just determine the maximum value of an element in array after performing these operation. So the maximum value we will get, we're just going to return that value. That would be our answer. Let's try to understand using this example. So we are this array given to us, and we have to convert it in a form where it will start from 1, and for all the elements the difference is not exceeding 1. So difference should be less than or equal to 1, and after that we just have to return the maximum value present in that array. Okay, so what we can do is like on the first approach came in my mind is like, why don't we go greedy and just sort the array and iterate that and find our answer. So if we sort this array, so it would be like this: 1 1 2 2 2, and first element is 1. First element like is 1, it is fine, and then after from second index till the last index, if we check for the difference, 1 and 1, it is 0, this is 1, this is 0, this is 0. So no, and not any difference is exceeding 1. So it is valid till last, and from this array we have to just return the maximum value, which is 2. Okay, so let's take another example: 2 2 1 5 1. Okay, if we go with this example, so what we will do is we will just sort this array: 1 1 2 2 5. This array is having positive integers only, so we are sure that it is going to have values from 1 to any value given to us. The constraint given to us is 10 raised to power 9, I think. So just we sorted this array. We are also given an option that we can decrease the value of an element to any smaller positive integer and rearrange it. So in the sorting we did the rearranging, and while doing the iteration, let's check. So for this index the difference is difference is 0, which is fine. For this it is 1, it is also fine. It is 0, fine. Now the difference is 3. Here at the last index the difference is 3, but the difference can be as a maximum of 0 or 1. It can't go beyond 1, and we have to return the maximum value from this array. So why don't you take the difference as 1? So after we have to make a distance 1, we can reduce 5 to 3. So after reducing 5 to 3, our array will look like this: 1 1 2 2 3, and 3 would be our answer, which is the maximum possible value in this array. Okay, so let's take another example as well. So 1 and 1000. Let's also quickly have a look on one more example. Let's say it is 100, 1 and 1000. So we are going to sort this array 1, 100 and 1000, and we are just iterating it and making it a valid result. So 200, like we can reduce it to either 1 or 2. Either 1 or 2 will be valid here, so the delta difference cannot exceed 1. So why just put 2 here? Because we need the maximum value from this array, right? So I'm just putting 2, reducing the 100 to 2, and after that we can reduce the 1000 to 3. So 3 would be our answer in this case. Firstly let's store the array. Arrays dot sort, we have sorted it. Also store the length of the array. Answer equal to 1, because we are going to have 1 at least in the array. Now what we will do is we will iterate from equal to 1 to I less than and I plus plus. I'm going from index 1, and at every index we will check if value of that element is greater than equal to answer. Answer here will specify the previous position. So let's say if we sort this array, it would be like this: 1 1 2 2 2. So firstly initialized our answer to 1. In this iteration I'm going to get the maximum value. So initialized my answer to the first index, and then from second index, which means index 1 to n, I'm just iterating this array and checking at every position if array ith element is greater than equal to answer plus 1. If it is 1, do we have to do anything? If the second element is 1, no, we don't have to do anything, we just move ahead. And then if it is 2, in that case we have to do one thing, we have to update our answer. So if the current element is less than the previous plus 1 at least, in that case we are just going to update our answer. Let's say if it was let's say in the last, if it was 6, let's say it was 6 somewhere. So if we are at 6, our previous element answer was 2. So for 6 is greater than equal to answer plus 1. In that case we'll just increment our answer, because 6 can be decremented to 3. So that's why we're just incrementing our answer. Answer equal to plus equal to 1 is fine, I think. Or maybe answer plus plus, and then in the end we'll just return the answer. Test cases are passed. Let's try to submit this program. Got submitted successfully. Okay, thank you guys.